All right, once again, welcome everybody. Today's session is going to be all about Civil 3D and looking at profiles and profile views. So should join the words together. I am Australian, I'm allowed to. And it's a 101 session. So we're going to look at the basics and we're going to look at all the pieces you need to make essentially a long section. So what is a long section? How do I make them in Civil 3D? Long sections are known in Civil 3D as profiles and profile views. And just like what everybody would be familiar with, the alignment is used as kind of the placeholder. It's the parent, so to speak. It controls a location in plan, and it is the placeholder that everything is attached to. Profiles are generally made from two different sources, but a variety of sources in general. Primarily, you would use terrain model information for your natural surface, or perhaps a design surface or an intermediate surface if you wanted to reference it. And then your actual design profiles are your vertical gradings, basically your vertical design of whatever it is you're looking to model. The profile view is what you use to show it in the drawing. Because you can make all these objects and they live as part of the drawing, but until you insert a profile view to display it, you can't really visualize it and see what's going on. Like all Civil 3D objects, labels and data bands are used to display information in various ways. So the label is just normal annotations that you would drop in over the view or over the profile. The data bands are tables of information that you would attach to your profile view. Now, the way these function are very similar, or almost identical in nature to the sections and section views. And if any of you have seen in my previous webcasts, I did one late last year on sections and section views on, I think it was around the 16th of December. So yeah, if you're interested in how this works from a section view perspective, go and have a look at that webcast. It is on our YouTube channel, as JT mentioned early on. So I'd strongly encourage you to go on that. And I'm going to follow a similar vein in how I'm presenting it, how I'm going to lay it out for you in this session.
Todd, at the end, I'll share the link.
Fantastic, thank you. All right, so today we're going to look at the basics of how the long section goes together, as I mentioned. There's a number of pieces that we go together, and I've kind of just described them, and I've done it in a different way now on the screen, just to reiterate that the things you need to know about. You need to know about alignments. You need to know about the data sources, the profile view layout, the data bands, labeling, and how you project things into it, including pipe networks or other profiles and so forth. Now, it's all good and well for me talking about this stuff, giving you the lists of descriptions. I think the best way to describe it is actually to show you a couple of pictures. So I've done a couple of graphics here. So this is a typical long section. This is something I've created in Civil 3D, and it's something we're going to go through today, just to break down what the pieces are that actually go together to make this layout. These things here are my profiles. So the green one is my existing surface, so it's extracted from a terrain model. The blue and orange one is actually my design profile, so that's something I create myself. The whole area here, highlighted blue, is the profile view itself. It's essentially a grid of information. And when it's inserted into the drawing, the axes get inverted. So the x-axis becomes your length along the alignment, and your y-axis is actually the elevation or the level of the profile. So it's like a localized change of space inside your Civil 3D drawing. The bands at the bottom here are the data bands. The collection of them is called a data band set, and each individual band can display different bits of information. So like you can see here, the bottom one showing my chainage, which is my length along my alignment. Then I've got a couple of other bands showing existing and design surface information. You can also annotate information about the alignment itself, so I can give it some of its horizontal geometry in graphical form. The other part that I've used in here to document additional information on my profile, in particular my design profile, is actually some labels to annotate the gradient of the tangents and the vertical curve details for all of my vertical curves. So I've got curve length, IP details, and grades coming in and out. And lastly, I've also showing in here some crossing pipe objects. So these things are highlighted on the screen here, so you can show these things in. There are other object types you can show in. We will have a play around with projecting in a Civil 3D block. And the last thing I'm going to show in here is showing up the ability to hatch between different profiles. So in this example here, I'm just hatching between the design and existing for cut and fill situations. I can see questions sitting on the chat about super elevation.
Yes.
I'm guessing you're about to ask me that, weren't you, JT?
Yes.
No, I'm not explicitly going to cover super elevation in this. This is just the basics of how you assemble your profiles together. So that's something we could always potentially explore in another session, but not in today's session, not in the scope, unfortunately. All right. So that's enough for the pretty pictures. Let's just talk about a bit of terminology, because Civil 3D actually has a couple of versions. So depending on which one you install, you get different names for different things. So I'm using the US version. So the terminology used in the software and the stuff that you'll potentially see on the screen are things like station, elevation, profile, profile view, section, model, PI, PVI, as you can see on the screen here. They actually mean different things in Australia. So station is your chainage, elevation is level, profile is actually what we would call a vertical grading. A profile view is essentially a long section plot. A section, as I mentioned earlier, is actually a cross section. Model is actually your three-dimensional view of the world. It's not the plan. And the interesting one that always catches me out is PI and PVI. So PI is just your horizontal point of intersection. So that's related to alignments. And PVI is your vertical intersection points. That's related to your profiles. Now, if you've installed the English version, or the UK version, I think its proper name is, the ones there with the stars, their actually terminology is changed in the software, and they actually will use chainage, level, they will use IP, and they will use VIP for the vertical point of intersection. So hopefully that will give you some guidance when I start showing different forms, and the terminology may look different to what you're familiar with, but essentially it'll still do the same thing. All right. Let's jump into the model. So the project I'm going to use here is actually the same project I was using when I did the sections webcast last year. It is just a data set that is of a potential subdivision. There's a number of alignments still sitting in the drawing in here. We're going to work primarily with road 1, which is this alignment here. We'll have a bit of a muck around with road 3 at some point. And there's also a pipe network sitting in here. I've got it hidden at the moment just to keep the drawing clearer. Surface-wise, there's just a terrain model, just a pretty stock standard NS sitting in here. We're going to use all that information, and we're going to develop up some long sections and deconstruct, I guess is probably the best way to approach it, all the pieces that needed to go together that make it, and how the basics of the styles work together to form that long section that I showed you in the picture before. All right, so let's get started. Okay, alignments, as I mentioned, are the primary placeholder of all information for your profiles in Civil 3D. So if I go in here and have a look, as I said, there's a number of alignments already made. I'm going to muck around with road 1. So at the moment, there is nothing sitting in here against road 1, but as we populate information, the profiles, the profile view sections here will begin to fill up with information. The sample line groups here is the holder of all information for sections. So it's still the same for the sections as it is for profiles. As I mentioned, the key to the whole thing is the alignment. You delete the alignment, you actually break everything. So don't ever delete your alignments if you developed all this information. All right. There's a number of ways of extracting information. So you can launch stuff from the ribbon, you can launch stuff from the object itself and the right-click menu, and you can also launch stuff from a context-sensitive menu when you select an object in the drawing. I'm going to use combinations of all of them. There is always at least 2 or 3 ways to launch a command. So the first thing we need to do to get some information going on our profile is actually to extract the natural surface against our road 1 alignment here. So if I pick my alignment in the drawing, not the labels, I pick the alignment itself, you'll get the context sensitive panel for road 1's alignment. And in here, there's a whole heap of tools that have been added, probably the common things that you're ever going to need to do with an alignment. And the one I'm after is here is to extract a surface profile against my alignment. So I run this command, and it will select the alignment for me. If you wanted to do it for a different alignment, you can actually drop the list down, pick whichever one you're after. You can also use the picker to pick it graphically in the drawing. However many surface or terrain models that exist in your drawing will be presented to you in a list. You nominate the one that you're interested in or ones you're interested in. You can extract more than one. You can then choose whether or not you want to extract it for the entire length. So the sample length here is something where you could key in a station. Remember, station and chain engine are the same thing. And as a bit of information, it'll actually report to you what the length of the alignment is. You could also use these pickers here to go out and pick it out in the drawing. You can actually even sample it at an offset distance. So you could offset it 1 meter, 2 meter, 3 meters off to the left or the right. Simply tick it on, type in the offset, and then you're away. I'm not going to do that. I'm just going to do a simple extraction down the center line. Once you've configured the properties of what you want to extract the way you want, you hit the add button and it'll populate into the list underneath. You can repeat that as many times for as many surfaces, offsets, or change ranges you're after. It'll just keep adding and adding profiles to the list, and they'll all get presented in your profile view, and you can manipulate how they look at that point. So as the list populates down here, there's a bit of information that's shown here for, bit of data shown here for information, and a bit of stuff that you can actually manipulate. So the name will come from the drawing settings that will be automatically put in if you've set it up. So mine is set to give me the name of the surface it's coming from and just increment it with a number. Because as I do these for multiple alignments, you'd imagine you're going to get pretty messy if you can all the same name. So it'll give a unique number to every surface profile I extract. Description field, like everything in Civil 3D, you have the ability to apply a description to an object, completely user definable. The type here is just a little graphic to tell you what type of type has been extracted. So this is the symbol for surface data. The design profiles will have a different symbol, so you will just at a glance be able to tell what type of object you're looking at. Data source is just simply the terrain model it's connected to. Offset, if you specified one, would be nominated here. Update behavior is an interesting one. When it's on automatic or dynamic, I refer to it as automatic because it makes more sense to me. But anyway, dynamic is essentially an automatic link to the terrain model whenever the data for that model updates. So imagine you've extracted a surface against data against a surface that you get additional survey information from at a later date. If you bind that information into your surface, if it's on dynamic, then the long section will automatically update with that information. If it's on static, it's essentially a once-off extraction, and then you get like a freeze, I guess, probably a good way to describe it. The surface data will be basically locked to what it was at the point of extraction. You can flip it to automatic or dynamic whenever you choose. You can get into the properties of it and just turn it back on. Layer, if this is left blank, it will use the layers as defined in the drawing settings. So in my one, I'm pretty sure it's going to create me a layer just for the profile. Can't remember exactly which one it is. I have to go and check the settings. If I wanted to nominate a specific layer, I can just click into the cell and nominate a layer that already exists in my drawing. You could always select the object and change the layer after it's created if you make a mistake and forget to set the layer if you wanted something here. Style. So this is something I'm going to leave for the moment, but I am going to come back and discuss once we've got a few things sitting in the drawing. But this is your chance to stylize the information. So there's a number of styles that I'm going to utilize out of this drawing, which is based off the Civil Survey Solutions drawing template. So existing surface is just a style that's set up to be basically a dash line, very much that green line that you saw in the schematic I showed at the beginning. So I might change that. And then station range and elevations is just reported for information. Now, this is one little tip I give everybody whenever I show this stuff. Don't click OK, because it will only create the profile. It won't give you the profile in the drawing. You actually need to click on the button here that says Draw in Profile View, this one here. And that will save the profile against the alignment for you, but then jump you into the next step, which is to insert the profile into the drawing. So we click on that one, and it'll jump us into the profile creation form. So this allows you to set all the information up for your profile view. Now, this is just the basics at the beginning. But the nice thing about all of this is all of this information is stored against the view and actually can be updated as you enhance data or objects against the profile. So we set the basics up the way we want now, and then we come back and refine it as we add additional information. It runs like a little wizard. So these down the left here are actually essentially new pages that appear over here. You can click on any old link, and it'll jump to that page. If you're not so familiar with what all the things are in each of the tabs, you can actually hit the next and the back button to jump backwards and forwards. So we'll go through them one at a time, but as you become used to how this thing runs, you probably will jump to the pieces that you're actually interested in changing, and then just go straight to the creating of the view and the drawing. So the general tab is the houser of all the basic information about the profile. So what the parent alignment is, the name convention that will be used for it. So very similar to a lot of the naming conventions in this drawing file. It's just going to use ls and then a counter. So as we build multiples of these, it'll be ls1, 2, 3, 4, 5. Yet again, another description field. Profile view style. So this is where you get to configure how the profile actually configures up in terms of the way it's displayed in the drawing. And the most fundamental control that you need to know about in those things is actually the vertical exaggeration, which is why all the styles here have got this 5x, 10x, 20x set in them. It's just at a glance to be able to know that this is going to show me what I would expect from my road layouts for the 5-time vertical exaggeration. We will deconstruct that at a later date, but this is where you get to pick it. So let's stick with the 5x. The layer, again, comes from the drawing settings. I'm going to use the defaults. If I had created offset alignments for my alignment, I could actually do offset, stack up my profiles at the same time. I'm not going to for this exercise, but that is certainly something you could do. So let's go to next. So now it'll start talking about the chainage range. Remember, chainage and station are interchangeable in terms of terms. So this is your chance to limit the length of the profile. So if you leave it on automatic, it will use the entire length of the alignment for you. And if you click it to user specified, then it gives you an option to then curtail it to a range. It's an interesting conundrum because typically you wouldn't necessarily want to do a long section of this entire road in one hit. You probably want to break it up into maybe 2 or 3 pieces to fit it onto your long section plans. But the way I normally run these things is the first one I make, I usually do the full length and I use it as a design profile. So it's kind of a tool I use to lay out and do all my vertical designs. And then I actually run another command in here, which is the multiple profile view creation, and allows me to extract a profile view in chunks along my alignment for me, and then it lays it out. And then I just enhance them with the data I want to see in my actual production drawings. Because you can have as many profile views as you like for a profile that exists in your alignment that exists in your drawing. You can have it repeated in the drawing 15 times in 15 different profile views. It'll show the exact same data for the same object types in all of the views, but you can customize them to look differently, but it's still showing the same physical data information. So we'll stick with automatic for the first one. We'll run the multi thing later on. Profile view height. This is your ability to curtail the height range. So the graphics at the bottom here are really handy because as you click on things, it will actually update to show you what you're changing. So if you specify a range of heights, you're curtailing the vertical region of the graph to whatever values you're asking for. The minimum maximums here are reported based off the data extracted against the profile for the surface that we've done against the alignment already. If you do the user version, you can actually then choose to split the view up. So the view will actually essentially have like datum breaks set in it. Again, I'm going to do that at a later date, but that's your chance to perhaps curtail the height change because you maybe have too much and it won't fit on a page properly. You can drop in some datum switches. And then you can edit those switches in the actual layout once it's gone into the drawing. Let's go automatic for the moment. Next, we're looking at the display of profiles. So as you add data and profiles to your alignment, they begin to populate in this list. So if we've done other surface data extractions, they'd be listed here. And at a fundamental level, you get to choose whether or not you want to include them, because maybe you don't want to show it in a version of one profile view, but in another. You can untick it. And then it is also your chance to, let's make it a bit bigger so you can see what's going on, to adjust the way it is displayed, because this is information here is the same as what we saw when we extracted it. There's the dynamic controls, there's the style controls. You could say that the style of the object is one style for it as by default, but you could override it in this particular view if you wanted to. So you can actually tick on override and you can say, you know, in this profile view only, I want to see it as existing surface 2 or something like that. So just because a style is applied to an object at its basic level doesn't mean you can't override it in a view. As they're added, you could automatically add labels. We don't want to for the NS because we really don't need to know what grade of every grade break on that is. It'd probably be pretty complex and way over detailed for what we're actually interested in. And then the rest of it's kind of just reporting the information that the object's extracted against. So we'll leave all the defaults the way they are. If there is a pressure network or a pipe network in your drawing, so in other words, anything populated in this section of your prospector, then this tab actually will be enabled. If there are no pipe networks existing, then that actually will be grayed out and you can't actually jump to it. We actually have one, as I mentioned, it's just hidden. I don't want to include it, but if I did, you'd tick on here and then you could selectively pick the pieces you want to include. We're going to add it in at a later date. So we'll skip that for the moment, and then we go to data bands. So this is your chance to configure initially how the information across the bottom of the profile goes. So currently it is using just surface levels only. If you drop the list down, you'll see that there's a number of sets. So very similar to the section views. The idea is each band is configured independently, and then a collection of bands can be saved as what's called a band set, and then that can be applied to a profile at the point of creation, which is exactly what we're doing here. So you don't have to manually create them every time. So we'll talk about that when we actually get the view in the drawing, and we'll actually look at what you can do. Once you've configured one the way you like, you can save the set out. So the next time you make one, you can just apply that set. We're just going to go simple design for the moment. So this is just going to allow me to get some basic information in my profile related to the design, the existing, and a station. Now, the way bands work is they always have this concept of a profile 1, profile 2. Now, the intention of these bands is profile 2 is essentially for information, for reference. Profile 1 is used as the point of which all the labels are actually dropped in the band. So it's best illustrated by an example. So if I can't change any of the profiles at the moment because we haven't created anything else, we've only got this natural surface 1. But essentially what's going to happen is every grade break on the surface is going to be labeled because that profile is nominated in profile 1. Whatever profile 1's grade breaks, IP details is used for populating information in the bands. As I said, once we make the design profile, they'll make a bit more sense. But all I'm going to say to everybody is be careful what you set profile 1 to, because that controls the frequency of ticks of data in your band. So in the names of all the styles that we've created in this template, we've actually nominated this P1, P2 in the brackets afterwards, which is the intention of the way information is intended to be extracted. So design will actually report the levels for whatever's nominated in profile 1. Existing will report the information nominated in profile 2. So generally, I would recommend you basically set profile 1 to your design, profile 2 to your existing. All right, geometry points is your ability to then choose which points of the nominated profile you actually want to use. So if you click on the little epsilon button, you can get this little band list up. So for a profile, it's basically going to show me all of my vertical geometry points, my high and low points, my vertical intersection points. Remember, that's VIP or PVI, depending on what version you're using. But it's not going to show me start and end or overall high and lows, but it is going to show me any grade breaks. If you go to alignment up the top here, you actually then get to pick which points along the alignment are used. So this is where the beginning and end gets ticked on. So there's no point ticking it on at the start and end of profile if they're the same as the alignment. Otherwise, you're getting duplication of information. So we've only set it once. So these are all the horizontal geometry points that we're interested in. So the nice thing about saving these sets when you make them is you actually get to save these configurations. Otherwise, you have to set them for each one as you add it each time. All right, next. Last bit is the hatching. Again, we've got nothing to hatch against, but we will be hatching some basic cut and fill areas once we do a design profile. So let's go and create our profile. So we run the command, and then we pick somewhere in our drawing where we want to put it. So let's put it over here. And then it will now show me my profile. So remember, in this little space here, the world is inverted. And if I keep my cursor still for a sec, you'll see here that, I think, keep the cursor still, there we go. The elevation is reported here as SZ. So remember, S is station, Z is elevation. So in this part of the world, it's thinking that the cursor is actually sitting at station 127.405 with an elevation of 25.14. But if I leave my cursor outside the profile view, my normal coordinate system takes back over and I'm sitting at, I don't know, something weird, whatever the numbers are down the bottom here, some massive, I don't know, was it 270,000 by 600? No, 6 million. So my normal MGA coordinates. All right.
Todd,
so now we've got a, yes.
Is there going to be discussion about changing the drawing scale, how that could impact the
yes,
the
we
scale?
are.
Yeah.
Yep.
Perfect,
Yep.
you.
Yeah. I'll do that once I do a bit more of the basic information into the profile.
Thank you.
No worries. So what we really need to have in here is essentially a second profile, second bit of information to essentially extract some details against. Just to illustrate what I was talking about at the beginning here, if I zoom right in on the profile here, you can see that design and existing are both reporting the same level information, and the frequency of those tags in here in the bands is quite high. And that's because this profile up here is extracted against the terrain model, and we're getting a grade break at the frequency of all of these tick points, which is why we're getting so much data down the bottom here. The moment we make a design profile and reassign profile 1 to be that design, the frequency of data across the bottom there will reduce dramatically. All right. Again, this is kind of chicken and the egg thing. You've got to make some of the data to be able to see some of the refinement of the data. So hopefully it'll make sense when we get to it. All right. Design profiles. So a design profile is basically the vertical design that you would apply for if you're building a corridor, or I don't know, maybe even using the basic controls for a grading object if you're going that far. You could even use it to represent a simple pipe network if you're interested in, rather than actually extracting pipe network objects. Whatever it is you're actually trying to model, the design profile is your chance of applying that information. So I'm going to do this based on the premise that this thing is actually a road. So before I do that, I'm actually going to just reconfigure the view a little bit, just to make it a little easier for everybody to see what's going on. So first thing I'm going to do is split my view into 2 viewports so that you can see the profile at the top, and in the bottom I'm going to show the plan so that you'll be able to see the context. But in the plan I'm going to swing it around a little bit so that I can make it a bit smaller. So we're just going to twist the view a bit. And I'll shrink it down a bit more too. And all right, so I don't want to show too much of this and make up too much space. I want to use as much as I can up top here. So up the top of my profile, down the bottom is my alignment, and on the analysis tab here, there's this thing over here called the station tracker. So if you flip that on for all viewports, when you're in the profile, hopefully everybody can see down the bottom here, there's actually this blue line that's dragging across. So as I drag through my profile, it actually gives me my horizontal position. And then the reverse is true. So I go into the plan, as I drag along, it gives me my vertical context to where I am in my profile. So the blue line will appear up here. So it's whichever one you're in, it gives you the opposite. So it just helps you to get that relationship between what is the start and end of your profile and your alignment, so you can hopefully get it the way you're expecting. Now, in terms of alignment profile creation, there's actually a couple of ways you can do it. You can do it IP-based, drop in new points where you want to create points of inflection. You can actually do it by element, and you can actually do it based on best fit entities. So I'm going to do the basic IP creation, probably, which I'm going to guess most people would typically use. By element is a bit more advanced and is not going to be covered in this session. But the idea of that one would be if there's certain points where you know you need a curve to appear or an IP to happen, you can draft all that in first and then connect everything up in between it. So you build it sort of segment by segment. IP, the intention is typically to build it going from start to end, which is exactly what we're going to do now. So let's go and make a new profile. So we'll go back to the home tab here, and then we go to profile. And this time we're going to go to this command here. So this is the other way you can launch commands. So that would be the command if I was extracting data against my surface. We're doing an actual design profile. So we run this command, and it will ask me down the command line here, which view am I going to do this in? So I click on my profile view. It'll ask me some information about the name and the style that I want to use for this. So once again, it'll connect it to my alignment. Naming convention comes from my drawing settings. So it's going to design 01 or something like that. It's good for this. Design style is probably what I want to use. And I'm going to let it automatically label my vertical curves as I design. So I'll deconstruct this after we've made it. There is also the ability to use some design criteria as you design if you want, and you can use that based on a potential minimum K table that you have either extracted or have obtained. I do have the Australian New Zealand country kit installed, which gives me the Osroad tables here. If you don't have it installed, then you're probably going to see the American, I think it's AASHTO tables. So if you do want to get hold of the Australian ones, download the ANZ country kit for your version of Civil 3D. And then this one is more of a geometric check for potentially VC length or even tangent grade or tangent length if you're after. That one's a bit more geometric. This one's a bit more design and sight distance related. We're not going to do those. We'll turn them on later and check our profile once we've made it. We're just going to do some basics at the moment. So click OK. It will then open up to this command bar. So very similar to if you were doing alignment layout, if you were doing grading, feature lines, all that sort of stuff. Same idea. It's a floating toolbar of commands that are specific for profile creation. So a quick rundown on what they do, and it will be quick because I am getting short on time if I just looked at the clock. This is your IP creation methods. These are some of your IP creation editing functions. This is more your component creation functions for tangents, component creation functions for curves. This is your ability to use stuff that you may have already drafted in the drawing, so AutoCAD lines or splines. This is then all the editing functions. So this is your ability to insert, these are your editing functions. This is tabular insertion. So this is basically your ability to insert IPs by table as opposed to clicking in the drawing. Raise lower, make a copy, how you then want to edit. So you can edit either by your IP information or by entity. Sometimes it's handy to run or the other. And then these are all the details of what you've created. And then you've got your undo and redo at the end. All right. As I said, I'm going to do a simple IP creation. I'm going to just draw a few pieces in the drawing, and then we're going to do a few edits just to show you what you can do. If you do want to just draw straight tangents and apply curvature afterwards, that's what this one is. If you want it to apply curves as you create, you'd run this. And if I put the design criteria on and extracted the appropriate K table, it would have tried to use those K values to apply the curvature. May or may not work depending on the geometry I pick, but it will do its best. Curve settings is if you don't have that set, then you can choose what type of curves get included. In Australia, we typically use parabolic curves. We don't use circular, or in rare cases we do. And asymmetric is essentially just two parabolics, just different on each end of the IP. I'm just going to go simple parabolics. Let's just go 40 for the defaults. We'll go draw tangents with curves, and then you start drafting basically. So I'm going to start at the beginning. I'm then going to drop in something in, I'll turn my snaps off, drop something in, I don't know, maybe here. And then let's go say maybe here, and then maybe somewhere up here. And then I go to the end. Let's go to the very end there. All right. So as with any other version of this command, this floating toolbar, when you finish doing something, you've got to press escape or enter to finish the command. So now I've got my profile setting in here, at least in the basic sense. We'll have a look at some of the edits that you can do with it. So I need to add potentially another IP in over here. That's what this one is for. So I go and include a new IP, I pick a point, drops my IP in for me. I can delete an IP, so I can come in and delete one I just made. And then I can also insert via the table. So this
So,
one I find, yes. Yeah,
sorry, interesting question is just coming
yep.
in. Whilst you're making these edits, is there any way to be able to see, I suppose you haven't really got a cross section because you haven't got any.
I haven't extracted any sample
No.
lines. If I had extracted the sample lines, then I could potentially show them up, but I'm not sure it'd be showing any information in there other than my existing surface, because I wouldn't have applied any sort of design to the section.
But it is possible though to have a cross section view of some sort open whilst you're making these long section edits.
Yes, but you wouldn't be seeing the long section in the view, so it wouldn't be. I can't see the benefit, because I need the profile to make the corridor, and I need the corridor to show the design in the section.
Yeah.
If I haven't made the profile, I can't make the corridor. I can't show the corridor in the section. So the only thing I'd be showing in my section would be my existing surface. So you could certainly do it, but I'm just not sure that it'd be that much use until you. It's again,
but later on down the line, it would be definitely.
Yeah.
Yeah.
But yeah, you can certainly do it afterwards. The whole idea of these object types is if you actually did this, made a corridor, and then did the corridor sections, and then did the section views, and then made some edits on the profile, that would update the corridor, which would then update the corridor sections. The whole lot becomes dynamic.
Yeah, so it's the section views really is where you'd be heading off to.
And in terms of presentation order, we've probably done it backwards in that we showed the section views first, and then did the profiles. But in reality, you would set up your profiles first, and then you set up your section views after you've made your corridor or whatever object it is you're doing, and then you would then do the editing on those things. And that's where you could potentially show section views underneath while I'm playing with the profile at the top, get the corridor rebuild, and then see all the updates in your section views.
Yeah, great.
That'd be the workflow I'd work from.
That's great. Yeah, well, we'll definitely get up that the link for that section views webcast at the end. Thanks, Todd. Cheers.
No worries. All right. So I was going to do a insert via tabular view. So it pops up this form. You get to pick the type of curve you want to put in. So I'm going to go parabolic. I'm then going to put a curve back in over here, but I'm going to put it in at a specific channage range and level that I'm after. So I want it at 508. I want an elevation of 36.5, and I want a curve length of 40 meters. So click OK, and it will go through and drop that thing in for me. So I find that a nicer way to insert, if I know the change I'm after, because I get to apply the curve at the same time. Whereas if I use this, I have to insert the IP, and then I have to add in the curve afterwards. So if you know where you're putting it, use the tabular entry. All right, you can most certainly graphically edit stuff in this drawing. These profiles are dynamic, as I talked about before. So when you click on the profile, you actually get a number of different groups showing up. So if I zoom in onto the first one here, square groups are essentially related to your tangents. So that's just like any sort of polyline edit group type concept, drag it around to the new location. The little circles are actually related to your curves, and that is your ability to graphically enlarge or shrink the curve that's applied between these two tangents. The triangle here is actually the position of the IP, and then the triangles here and here are actually dragging the IP, constraining the grade, either the in or the out grade. So let's move a few things around. So if I grab this IP in the middle here, you'll see that I can move it wherever I want. And it gives me a nice graphic of what the design will look like. And then when I do something it can't cope with, it just doesn't give me a preview because it's not possible. So I could come in here and attempt to fit this to my existing grade. So maybe there. So it's just left click to drop things. And then if I want to perhaps fit this position in a little nicer, I could grab this IP here and constrain the grade to match to that, and then go, yeah, okay, that's a better position for that. And then if I wanted to change the curve, I could actually grab any of the three circles and drag it, and it will decrease the curvature of the vertical curve that I'm applying at that point. So I can do all of those things at any time. I can also edit this information from a numerical point of view. So it's called a layout edit. So that's where all of these commands kick in. So I'm currently in PVI mode, and I click on the PVI I'm interested in, and it will populate graphically on the drawing all the numerical information in this little window. If this window is closed, if you click on the cross and then you're clicking on this thing and you can't get it to come back up, you actually use this button here to turn it back on. So you click it on, and then you click on the IP. So some people get a bit lost with that one. If that disappears, if you closed it accidentally, you've got to actually turn it back on by clicking on this button a couple of times and then click on the IP you're interested in. And then you'll be able to make some changes. So anything black is changeable. So up here, I could actually play around with the position. So maybe that thing's not meant to be in the right spot. I wanted it somewhere a bit further over near 200. So let's go, say, I don't know, 208. I like my 8s. And then let's change the RL of that to something like this. Oops, 40.1. And then let's change the curve length. Let's maybe make it 60 meters. So the one I've been changing here. So as I'm changing the data in here, you can see that the graphic keeps catching up. All right. I will close that down because I don't want to do another one there. The other edit I would like to show you is changing the mode here. So if I flip the mode out to my entity mode, so this picker then changes. So it actually now become pick an entity as opposed to pick a IP. So I can then now go and say pick on my tangent here. If I turn my box on. Now it's showing me just the information related to that tangent. If I clicked on a vertical curve, it's showing me just the curve information as opposed to the IP. So when I was in IP mode, it was showing me the curve details plus the incoming and outgoing grades. So this is another way to view your data just as unique elements. Instead of seeing individuals too, you can actually see all this information in a complete grid view. So this green dot one is actually the grid view version. So when you're in grid view, you can actually pick on an element in here, and this is your panorama type window where you can scroll things across. So this is where you can actually see a whole heap of information about what is shown for the particular IP. And just to freak everybody out, there's actually probably half of it turned off. By default, only the things with the ticks are shown. You can actually show a whole lot more information if you're interested in it. If you flipped it back to entity mode, then that actually updates and becomes the entity version. And then when you grab an entity up here, can you see the big drawings? In the drawing, it'll actually flash up which IP you're playing with when you click on it down here so that you can work out where you are. So if you want to modify just VC lengths and incoming outgoing grades, this is probably the better view to use because you can do it far quicker. All right, let's add in a new IP. So I'm going to do one near the end here. I don't know, somewhere there, that'll do. This actually, it's not a bad position. I actually wanted to get it roughly matching that. I need to potentially adjust its location though, because I want to make sure that it sort of fits both grades. So let's go with, it actually wasn't a bad guess, to be honest, where I was aiming for. Let's go something like that. I now want to apply a vertical curve through here. So I mentioned that you can use these tools in here for component layout, but in reality, you can actually use them for basically applying the vertical curve here. So the one you'd be looking for is what's called a free vertical curve. So I find the terminology backwards, to be honest. Free actually means that it is essentially linked to an incoming and outgoing element. So this is very much like the alignment layout tools. And fixed is actually where you are defining all of the component elements. So to put a curve between two tangents, you actually need to use a free curve. So you could go free parabolic curve, and then you would actually have to specify the incoming outgoing elements. The one I actually would recommend using is actually to do a free vertical parabola PVI based. The reason for that is because then you just have to nominate the IP you want to actually manipulate and then just type in the length. You don't have to pick incoming, outgoing elements. So we click on this one and form goes nuts. Down the command line here, it's asking me for curve length. I could nominate a particular K I'm after or a particular pass-through point, or you can nominate the value you want. I want a 25 meter length VC, type in the value, press escape to finish, and I've now got my 25 meter vertical curve in here just to fit in to my very end. So if you're adding stuff after you've added in a few extra IPs, always recommend you using this one here. Unfortunately, it is buried under the more free vertical curves, but I find it the better one to use. All right. What else? It's probably, raise and lower is the other one that might be useful for people. So I'll show you how that works. So raise and lower is this one here. So if I run this command, it allows you to choose the entire profile, which is all, or a specific range. So if I say I only want to apply this from, say, 0 to 200, so just the beginning here, and I want to raise the whole thing a meter, I'll click OK. Then it basically will find any IP within the range I'm asked for and raise it 1 meter. So yeah, you can use that to adjust different pieces if you want to. All right. I mentioned the criteria check. So let's apply that to our object. So go into the properties of our profile, and under the design criteria tab, you tick on that you want to use a criteria, and then you want to use a criteria file. And if you go out and look at your files, you'll be able to see a bundle of these. As I said, I have the ANZ country kit in here, which is why I'm getting these. You nominate the table you want, you then pick the table you're after, and if you wanted to potentially check your curve lengths, you could turn that on, use one of your other more geometric checks. I'm not going to worry about that. And you apply that. And the other thing that you need to do, which I forgot to adjust, I will apologize, you actually need to set the design speed, and that comes from the alignment. So if I go to the alignment properties and I go to its design criteria, it's currently trying to do a 100-kilometre-hour road, which is probably way too quick. I actually probably want that to be 50. It's only a local street, so let's set it to 50. And then I need to come back to my profile, and I probably need to refresh that because it will have done that original check at 100k an hour. So I need to pick my table, apply that, and I'm getting warning signs at every VC. So now let's go and work out where they come from. So if I go back into the geometry of the profile and I go to my layout, you can get the warnings listed here, and you can actually click on a particular IP and you actually get to see the warning up the top here as well. It is also documented across here. So there's my design speed at 50. It's using the 2016 table. And it is basically telling me that my minimum K for the site distance should be 10, but I've actually only got 3. So in other words, I've screwed it up quite badly. So I need to make a design decision here whether or not I need to adjust my vertical curve length or whether or not I want to ignore the rule at my own peril. If I then picked a different IP, you could go and see what's going on with this one. So this one here, it's actually K value of nearly 8, and the site distance criteria is 7, so I'm actually good. It's the stopping site distance one that's killing me here. I actually need it to be 154 meters, which to me seems a bit insane for a local street. But anyway, so it is now a user choice as to whether or not you want to make manipulations. So you can come in and start making changes to your vertical design, but that is a design decision. All right. Now let's have a look at updating the bands underneath. So underneath at the moment, I'm still showing just existing information. So to give ourselves a bit more room, I might actually switch the world back to a single viewport. We don't really need to see the plan anymore. Hopefully this will make things a little easier. So to circle back to a question that JT raised in terms of about the size of this, the size of all these things come from the current drawing scale. So my current scale is actually 1 to 200. So it's scaling the entire thing down to fit everything in terms of text based on the definition to what works at 1 to 200. So if I flip it out to say 1 to 500, all my text gets bigger. The profile doesn't change because it's a geometric thing, but all the labeling does. But because I'm getting so much labeling going on, it way blow past the end of my profile because it can't fit physically everything in. That's fine. As we actually change the data underneath here, you'll see what happens. So if I go into my profile view properties and I go to the bands tab, so this is where you get your chance to adjust anything that we set at the initial creation. So bands here, I basically come in and say, I want to use profile 1 as design 1 for all 3 bands. And then I go, okay. And now suddenly all the information underneath only gets reported at either the minor frequency that I've applied to my view, which is going to be every 10 meters, or at all of the horizontal IP points. And then wherever there's overlap, it's actually automatically applying a crank. So this is your nice way of controlling what gets included. So the way the bands work, essentially the controls that you've got set up here actually impact the staggering. So let me illustrate, because I think an illustration is actually a better way to do this. I got my profile in slightly the wrong spot, rather than me talking. So let's add a new band in. So we're going to go, I want profile data. I want to use something simple like my depth. Add that band in. And when you add a band in, it will ask you 2 bits of information about how to report that in the band. It's all related to the profile and alignment points. So I want to set the profile points to being not at my profile start, because they're coming from my alignment and not the overall. So this will match up with what I've done before. And I click OK. And then if I apply that, bugger, didn't make it quite high enough. You'll see there's a new band coming in, but you'll see that all of the information is empty and it's moved away and it's more frequent than the others. There's actually some extra labels going in here that shouldn't exist. That's all coming from the settings that I haven't finished setting up. So number one, there is the ability to control the gap here. So that's this gap here. So change it to 0, and then we apply that. There we go. And I hit OK, not apply, because I couldn't see the button. And now the thing sits at the bottom. In terms of weeding, so weeding is how frequent these labels get masked away. So at the moment, every label that overlaps within 100 units of each other gets wiped out. I don't want that. I actually want the thing to stagger. So if I put 0 for the weeding and then apply that, I will get all my labels coming back. What I need to do is actually set the profile controls, because it's now labeling based on the frequency from NS. Remember, it's profile 1 that controls the frequency. If I've now flipped this out to being design and then apply that, it's now labeling at the same frequency as the others, but there's no staggering going on because it's the stagger control sitting here. So I need to say I want to stagger to the right, and I don't need to specify a distance because the stagger comes from the first one. So if I apply that, now all my staggers match up with everything else. But now I'm getting these mystery labels here. There's another one here. They're actually coming from my horizontal geometry because I neglected to review the alignment points, and it's actually labeling my curve midpoints. If I turn that off and then apply that, they disappear because I don't want those. I'm not interested in the curve midpoint. So when you review those geometry points, make sure you review the alignment and the profile. All right. I actually potentially want my depth controls to be at the top. So if I grab that and use these sorting buttons on the side here, I can push it to the top. If I apply that and then break my stagger, because the stagger controls need to be applied to the first, not the mid. You'll see that the stagger labels kick in here. What you do is you reset that one to 0 and you put that to your 3, and then you apply that, and then the stagger gets applied to the first one, and then the others keep the same stagger. All right. That's it in terms of manipulating the data bands. The only thing I wanted to mention is I talked about these things called band sets. If you actually wanted to apply a completely new band set, you could click in here and go import band set, and there's some preset stuff set up in here. Or if you have set up one that you like, that you want to use next time, you actually go save band set. It'll ask you to review the information just to make sure it is what you want. And then you click OK, give the thing a name, and you are able to use it for another profile that you make later on. I'm actually going to make one because I've got all the ones I want, but when we make another profile shortly, we will actually apply a different band set just to show you the differences. But yeah, I wouldn't recommend having to set this stuff up all the time. Once you've got one the way you like, definitely save the band set and apply that as you create new ones. All right, let's update the profile in terms of the hatching information. I did say I was going to show you this, but there was no point showing it to you until I had a couple of profiles to work from. So if I go out and show my entire profile. Another tip, when you're picking the profile, make sure you don't pick something like that or something like that, because that's the actual profile. To get the profile view, I actually recommend picking probably one of the heading bands. It's easier. So you'll know you get the profile view, number one, it'll tell you up the top. Number two, you only get a single grip for it, which allows you to reposition it, but the rest of it is all gripless. That's the way you know you've got the profile view. Let's go profile view properties. And in here, I want to look at my hatching. I want to apply a cut and I want to apply a fill. Nicely, it knows that I want to use the two different profiles for the two different bits, but if you have multiples, this is where you could change which is the upper and lower boundaries. We click on OK, and now I've got my profiles sitting in here showing me my cut and fill information, and that stuff's dynamic to my design. So if I came to this profile IP here and actually went, you know what, that vertical curve is not quite what I wanted, it really needs to be something like this, you'll see that the hatching keeps up with it. So you can apply that hatching at any point in time. But it's a nice way to annotate when you're in cut and fill. All right, the style. So I mentioned styles for profiles are not dissimilar to alignment styles, and if I didn't, then they're not too different to alignment styles. So if I grab on one of these styles here and I actually go and look at my profile style, it's essentially, if I look on the display tab, because that's really the kicker, it's essentially just a collection of elements, very much like an alignment style. You can control what line, curves, symmetrical and asymmetrical parabolas look like, and then some extension information, arrow information, and then also the warning symbols. So if I want to show the warning symbols, sorry, not show the warning symbols, I can just turn the globe off. The other thing you have to bear in mind is these can actually be displayed in different views, so make sure your view direction is the way you want to see it. Profile is what I'm looking at right now. Model is actually a 3D view. When I go to model, you actually only get to see the object as a 3D combination of the alignment geometry and the profile geometry combined. And in the section, I think you only get to see it as a marker in the section view. The 3D representation of the combination of the profile and the alignment, the tessellation, so how accurately the curves are modeled, comes from the value defined here. The smaller the number, the more tessellated the curve, the more accurate representation you get. Markers are all about potential IP and start and beginning points. So again, very much like alignment styles. Arrowhead, same deal. You can control what the arrows would look like if you turn them on, which I am actually going to do in our profiles just to help with my direction. So if I make some changes to this stuff and click OK, it will modify the style. And if I actually look at my profile here, you'll now see I'm getting some arrows showing my direction. So it's always handy to know which way things go. But if you don't want them, you can turn them off. I don't get to see the marker warnings anymore. They still exist. I just turned them off because I'm going to work on ignorant bliss. The profile view style is the kind of the placeholder layout. So if I grab the profile view again, and up here, if I go to my profile view properties in my quick start and go, I want to edit the style. I'm going to talk about this in, I know I'm running short on time, in a few minutes. So the critical one that is the most important, and I stress this in the names, is the vertical exaggeration. So this is currently set to 5. And what I'm actually going to do, I'm going to do this a little different. If I bring up profile properties this way, I can still change my styles from here, but I can actually jump into create and edit. And we're actually going to make a copy of this style. We're going to make a new one. We're actually going to make one that is only got a 2 times exaggeration. We'll go something like 2x. So over here, you basically say, I want to exaggerate vertically by 2. It will look at the current scale of the drawing and then apply it ratio. So in other words, my vertical will suddenly become 250 because my horizontal is 500. So it's exaggerating the thing 2 times. If I increase that number to 10, then it obviously would go to 50. My suggestion is you configure one of these styles the way you like, and then you make clones of the style and just change the exaggeration so that you can quickly switch your vertical exaggeration on your profile view, depending on what you're after. In terms of the pieces, the information is naming option and descriptions. So yet again, another description. Grid is your opportunity to define the basics of the grid inside the profile. So remember, the grid is essentially where the profiles exist in that vertical space. And it is a graph. At the end of the day, you could actually have horizontal and vertical lines to represent all your graph elements. And you can clip those things. So to make it look like a long section that is traditionally the way we draft in Australia, we've actually basically omitted most of the grid lines and set them all to clip to the design, which is what all these settings do. So this is your option to clip the grid vertically and clip to the highest profile. So whatever one's highest, it'll clip to that. And the same deal with horizontal grid. If I turn them on, they'd be clipped to that. Underneath here is your ability to build buffers into the grid. So at the top, it's adding one extra major grid, which is why there's a space here at the top. And it's adding 2 grids at the bottom to give me a bit of space at the bottom for some labeling. I could actually increase that. So let's go maybe 5 for that, just to have a bit of fun, show you the difference. The title annotation is your ability to control names, labeling. So the title is the orange line at the top here, and it is configured from the graph view title section here. So you can configure position, top, center. You can give it offsets from X and Y perspective. You can set a height of text. So remember, heights of objects in Civil 3D in terms of labeling always are a ratio of the drawing scale or the viewport scale if you're showing it in that. And then the contents comes from whatever's set here. So very much like a component label, you can get into the properties. You can then push some property information across. So this thing will base it based on a combination of alignment name and the graph view name. So in other words, it'll probably call it road 1, longitudinal section, LS1. All right. And then the axis. So remember, it actually is meant to be a graph in basic level. So you've got 4 axes that you can define. So we've actually hijacked the top axes and set it as the scale. The reason we did that was so that the text height could be smaller, because we wanted that as more of a information as opposed to a dominating title. And we've used the left axis as a definition of the datum. So it's the minimum elevation in the profile. And then there are controls here for each of these. So manipulating axes, you've got to pick the one you want to manipulate, set all the values, pick the next one, go round and round in the 4 points. Horizontal and vertical axes is your ability to control the grids. So the graphic at the top will show you what you're playing with, but basically the horizontal axis is essentially all the vertical lines. We are using those. We are showing them at a 100-meter interval for the majors and 10 for the minors, which is where all the 10-meter vertical lines are coming from. The text here would be as if you were showing the grid labels for each grid line. We're not, so I'm not going to bother just deciphering what they actually do, but if you do want to turn them on, this is where you set the values. The vertical axes we pretty much aren't using for anything in terms of display in the drawing, other than we're using the major interval as the definition of that buffer. So I said 5 major intervals at 2 meters. So basically there's going to be a 10-meter shift between the datum and the lowest profile before it starts putting the profiles into my drawing. So basically a combination of this value and this value are used to do that shift at the bottom. Display is where you actually turn on and off all the pieces you want. So as I mentioned, we've disabled from display the bulk of the information. We want the title, we want the left axis title because that's our datum. We then don't want any of the annotations for the left and right axes information, nor any of the axes themselves. We are actually only showing the top axis title, which is my scale setting up over here. And then we are showing the vertical grids for the major and the minor and the horizontal geometry points. And then we're not showing any of the other vertical lines. And we're also showing the hatches. So that is controlling what is and isn't displayed in my drawing. If I actually apply this, you'll see that the thing shifts. So now my vertical exaggeration drops. And now I'm only seeing a profile at 1:2 ratio. All right. Now, I know I'm running short on time, Jonathan. I do have a few more things I wanted to show.
No, go for it.
So I apologize to everybody, but it'll probably be another 10, 15 minutes of stuff I think you might be interested in. Labeling of the profiles. So I have configured my labels in here to happen automatically as I drafted my design profile, but I probably need to just dissect what I did. So all the design labeling is actually this stuff here. So it's actually all the IP details and the IP vertical lines. And the way I did it is I used a label set. So we can get rid of that. If I go to the profile and I go to my profile labels, so what I've set up is essentially for all lines, crest curves and sag curves, because they are actually documented differently, I've told the software I want to drop in a style called a vertical line. So it's actually anchoring to the beginning end of each curve or tangent and then dropping to the bottom of the grid. So that's how I'm actually getting these lines to appear in here. Probably the best way to illustrate is if I actually turn them all off, apply that, all the labels disappear, but you'll see that there are some ticks here that are no longer getting information because they're coming from the vertical details. So this one here will be probably the low point. This one will be the beginning point of the thing, the beginning of the tangent or the end of the curve. And this will be the end of this tangent or the beginning of the curve here. So we need to draw those lines in. So that's what we've used in terms of those label types. To save you having to do it each time, there is a label set that we've set up in this drawing that actually applies it all automatically. It's this VC labeling. So if I add that back in, that's where this one, and this one all come from. So if I disabled all of those, they'd all disappear. This entry here is giving me my grades. So I need to apply this so that you can see what's going on. So for all of my lines, it is essentially giving me my incoming, outgoing tangent grade for each of the straights. And you'll notice that it sits here at the bottom, and that's because whenever you add labels, you have this ability to anchor the label to a certain point of the graph. So we're actually anchoring those labels to the graph view bottom, and then we're referencing that point and saying 10 millimeters above that is where I want to label the actual line work, and then everything's anchored to that point. To illustrate, if I made that say 15 and applied it, see how they all jump up? And they're all getting on top of each other. So this is the actual control giving me that positioning thing. It's only because I've anchored to the bottom of the view. If I anchored it to the top, that'll be happening at the top. What else we got? So we got the curve lines for the sag and the crest curves. They're the same thing. They are essentially the same idea as these grade lines, but they are now this one. And these ones are anchored 20 millimeters above because I want to sit there. And then the last piece is the IP details, which is this one here, and that's anchored 30 millimeters above. So I'm using them to stack them up on top of each other, which is why I buffered up that bottom gap in my profile view to allow me space to fit this information in. But perhaps I want to label my low points. I actually want to label my low point on each of my sags, and I want to label all my high points on my crests. So I can do that by going in here and going for my sag curves here. I want to pick my low point label, and I add that. And then if I apply that, sorry about that, apply that, I'm now getting a label sitting in here at my low point. And then if I did the same thing for the crest, this time pick the high point version and apply that. Add that, then apply that. If I jump out and go and look at one of my high points, so now it's nominating the high point for me, which is also happening underneath. So it's just doubling up. Perhaps I would modify that view style to just say high point. Again, it's up to the user to configure how they see fit, but that's probably what I would do, would just simply say high point, low point. All right. The other thing you can do is actually annotate labels within the view itself. So if I click on my view again and I go, I want to add in what's called a station elevation label, you can actually then nominate a particular point in your view and it will label that up for you. If you want to do it at a specific change in elevation, you can actually use the transparent commands here. So I can say in here, I want station elevation. And then I pick the view I want to get that reference from. So in here, so now it'll ask me for station. So I could type in a value. So maybe I want that at 165. And my elevation for that, perhaps I want it at 30. And then when I finish that, I'm getting a label now sitting in, oh, I obviously didn't type the 30, but it's at 165. And if I'd actually typed 30 and applied it properly, it would have put in the elevation at 30. But you can also grab these things. So if you get them in the wrong spots, you can actually reposition, and you can still use those transparent commands to reposition. So you could run that station elevation again and pick a new point. You can also snap. So if I wanted to snap to something, I could also just use my snaps and go, I want the nearest snap there. And it'll tell me the particular change in elevation of wherever I've snapped. The other label type you can add into these things is essentially a depth label. Oops, grab the right command. Depth label here. So this one allows you to pick 2 points, and it'll give you the depth between them. So if I go from here to here, it'll tell me the depth between those 2 points is nearly 8 meters. Again, I can drag them around. I could potentially snap this thing to my surface, and I could snap it to my design. Intersection there. There you go. My depth supposedly here is 0.242. And if I look down here, oh, look at that. It's 0.242. But you can do that anywhere you like, and you can use your normal object snaps to annotate that information up. Okay, let's have a quick look at projecting data. So you can project a few different things into your profiles. You can project AutoCAD points, blocks, 3D solids, 3D polylines. You can also bring in Civil 3D Cogo points, feature lines, survey figures. You can even bring in bridges that you might have done through InfraWorks. And then the way they're represented in your profile is actually via styles. Because they're universal, these projections, the styles, this is a tip I'll give everybody, the style definition for your projections actually is a multi-purpose style. It comes from this entry here in your settings, not under profile views. So don't go looking under profile views to find it. These are all of the projection styles that are used to project things into the drawing. And that's what I'm actually going to show you. I'm going to put, very much like I did in my section view webcast, I'm going to project a light pole into my profile here. So I have a block sitting here in my drawing. It does have an elevation, but it's probably wrong. I think I might have projected it to the surface. Can't remember. Doesn't matter. Because when you do these projections, you can override the elevations that are used. So the way it works is you come in here to profile views and you go, I want to project an object to my view, pick said object. You then, and you can pick multiples. You then pick said view. It'll then open up a little dialog box like this and allow you to configure it. It'll tell you what type of object you selected and however many you picked. And then you can pick a style to control it. So I'm going to say I want a light pole. This style here is a multi-purpose style. So make sure you pick the profile object type you're actually interested in modifying. And I've told it when I'm showing this thing in a profile, I actually want to use another block. I want to use this block called Streetlight. And I did find that it seems to use a weird boundary for the definition of this thing. And I actually had to edit the block and add in a buffer by adding in a node in the bottom of the block to make it work. So I'm not sure what's going on there, and this is something I'm going to take up with Autodesk. But if you do find that it's not going in the position you want, you do actually need to edit your block just to shift it. It doesn't seem to happen to anything else, it just seems to happen to profiles. So I'm not sure what's going on. But the key one is I've ticked on this vertical exaggeration. So it will stretch the block based on the vertical exaggeration of the profile view. All right, so I want to go light pole, elevation control. I could use the object I've nominated, or I can actually use one of my profiles. So I want to project it to my design. And we're going to change label and label. Oh, there it is. I'm going to drag it that way. There you go. So it's going to give me my label based on, there you go, a label line, change in level. Bang. Let's do that. So there's my block. Stretched vertically. It's now showing me my change and design elevation at that point. And then you can see that little block that I've added in here to shift it up. No idea why I needed to do that, but that's the reality of it. If I wanted to edit that, you can actually get back into these things. If you go into the profile view properties, you'll get now an extra tab called projections. So you can also always come back to edit these things through the properties of the profile view. All right. Let's put in some pipe networks. So I just need to turn it on. And I think I found that I froze them all, so I got to thaw them. All right, so there is a pipe network, or actually a couple of pipes, one pipe network, but with multiple branches sitting in here in my drawing. I want to show this in my profile view. So the way I find that's the best way to do this thing is to actually get into the properties of the profile view. And you'll notice that there's no entry in here for pipes, but as you add them, you can get to those properties. But because we never added it at the beginning, you can't add it until you can't see it until you've added information. So the way you add it is back from this profile views section on the home tab, profile views and section views drop down controls, and it's this option in here. No, sorry, I apologize. It's not in here. You've got to pick the profile view first. I always forget this bit. Pick the view, and there's an option in here to go draw parts in profile view. That's the command you're looking for. And then it'll say, what network do you want to project? And I just pick anything on the network. And then I click enter, and it'll pick up the entire network. And then I press enter again if I want to deselect. And then if I want to pick others, so I go pick the profile view. And it will show every pipe and pit in my profile view, which is not necessarily what I want, because some of these are coming from sections over here for a profile over here. I could have picked individual parts, and I could have gone through and nominated these specific crossing pipes that I wanted to show, but I like to do things as efficient as possible. And what I actually found is if you add the entire network first and then get into the profile view properties, you'll notice there's now a pipe networks tab. In here, you can actually then go in and pick the entire network and disable it from view. So if I apply that, it'll go back to what it was. But then there's an option down the bottom here, which allows you to only show the things that are crossing. So it filters it out to only show me the objects that are crossing, which are these 6 pipes. And then I can grab all 6 pipes, turn them back on. And then if I don't override their styles, they will show up as a projection. So they will actually show me beginning and end of the pipe in 3-dimensional space. So I'll see each pipe's as some sort of, well, let's apply it and show you. So you can see here that that pipe is actually showing, because it's not running perfectly perpendicular, it's going to show as an actual 3D object in the profile. I don't want that. I actually want to show them as just their crossing points, because this is a slice through my model. So I can override in this view that I want to see my drainage pipes in just a crossing style. So it's essentially a style that only shows the crossing point. I click OK and apply that. And then each of those now are just showing me my crossing points. The nice thing about these things, they are linked to my profile, sorry, my pipe network. So if there was changes to those, these things would update in here. But I find that the fastest way to actually get just the crossing objects to show. And you can see I'm a pretty bad designer because I put that pipe at the surface. All fun, no responsibility in terms of designs. The next thing I want to show you, again, geez, I'm running way behind. I'm going to do this one really fast. I'm going to show you how to extract a pipe network profile long section. So I have a pipe network sitting in here. I need an alignment, and then I need a surface, and then I need a profile view. So the software actually has a lot of that built in for you. So you can actually nominate your elements you want to extract things from. So if I pick my first pit down here at the bottom, which is my outlet point, and I go, I want to create an alignment from the network. And then it will ask me to pick my next upstream point. So let's do the first branch. So it should bring me up to here. So it'll highlight the whole thing for me. That's good. I then give it some properties. That's all good, but I'm going to just do geometry only. And then if you leave this option ticked on, it'll jump you into the steps to make the profile and then the view of all the information. So I go, okay, it'll jump me to my profile extraction, auto picks my alignment, NS, great, add, create my profile view. In my profile view, I can change how the thing displays. Really, the only thing I need to worry about is pipes. I want to show that network, obviously, and I want to show a data bands that are related to pipes. So I'm going to go drainage pipes, and I don't have a second profile, so it doesn't matter. I don't need to set it, but the data source for the pipe information, you need to make sure that is on your network name, which it should auto pick for you, but that's your ability to then set what data comes in the bands for pipe object bands. Let's go and make the view, and we put it over here. So it's now dropped in a pipe long section for me for that first branch. Then you'll notice that the chainage here is missing. It's all question marks, because whilst I've made the alignment, I haven't actually associated the alignment to my objects. So what you need to do is get into your network, and then you need to also label your network so you know which bit you're working from. So let's go entire network profile, pipe data. Let's just go name, crossing, we'll go none. We'll add that. All right, cool. So we need to go from 14 right through to 1. So what you do is you go to your grid view of your pipes, and you, sorry, not your pipes, your structures. We basically want to set from 0 to 14. This one here is a reference alignment. Expand the name. If you right click on the heading, you can actually go edit, and you can pick the alignment that that object's referenced to. And then if you apply that, now that information is reporting from the alignment object that's been created over the top. All right, that's how you do a long section for pipes. If you were doing a branch, you'd do the same process. So if we go from this point here to do the next branch, and we go make an alignment from the network, we go to here. Same deal. Let's go that. We're going pipes, pressure network, good, data bands, pipes, create. Once you know how you're doing this stuff, it's actually pretty quick. Same deal. So it's made my network, but my alignment's up the putts. I need to do the same trick I did before. So I need to get into the network properties, go into my structures, and this time I need to go from, I think it's 17 to 15. 1, 2, 3, yep. And I need to edit that reference, make it to that one. Apply that, apply that. But there's a jump. That's because this is going from 0 on that alignment. And the way you fix that is really easy. You go to your alignment properties for the second alignment, and you actually reset the station at the beginning to be the branch station. So I go 85.271. Okay. And now all of those now are starting from the correct branch. All right. Last thing I want to show you was that multiple profile creation. So again, I apologize, I've gone way over time, but let's do this one real quick. So I go here, I want to create multiple profile views from road 1, LS whatever, 5X, that's good. I want to station range, full thing, length of each view, let's make that say 250 meters. Yeah, let's go auto for the heights, display control, yep, they're all good. Pressure network, no, we don't want that. Data bands, we will do simple design. No, we'll do road design. Remember to put this as profile 1. Done. Next, hatching, yeah, we can add those in. And multiple plots. So this is how it lays it out. Let's go 4 across, but let's say only 50 apart. And then you go create the views, and you push down, and it will drop in the views for each one. Oh, and I forgot to set chainage profile band style. But anyway, and now I've got a profile view for each piece. So it's 250, 250, 250. And then I can refine these to suit what it is I might be wanting to present. The nice thing that you can do here is that the design in one is actually linked to the other. So if I highlight that profile, you notice you actually get it in all of them. And if I make some dramatic changes, so if I grab this and shift it up, you'll see that I'm getting those changes impacted on all versions of that profile in whatever view it's displaying in. So they're dynamically linked. They're the same object displayed in multiple ways. All right. The very last thing I wanted to show you was superimposed profiles. And I need to do that from another alignment. So I am very quickly going to grab this alignment here and make a profile for this. NS, profile view, that'll do. And don't care, let's go straight to creation. And then make a profile in here. So make one for this, bang, that'll do. That was wrong. Didn't want to do that. I actually wanted to do the best fit just to show you how that worked. So if I grab this, I say I want to go from a surface. I can weed it if I want, but I'm actually going to use the defaults. Going to go against that surface. This is maximum length of radial. So careful, this is not curve length, it's radial maximum radius. Just leave all the defaults. I won't show the report. Create thing. And I forgot to change the style. This then is a best fitted profile against the surface. So it's tried to fit as best it can to match the surface vertical curvature. Now, the reason I wanted to do this was to show you what happens. I want to show this profile on this long section. And you do that used a command called Superimposed Profile. So it'll ask you which one do you want to have as a source. So I pick this one, and then it'll say what destination, and I want to apply it to this one. It'll ask me for what range and how accurate I want it. So I'll leave all those. And then what it will do is actually show me a new profile in my profile over here my profile view over here that is related to this one. And then that means if I start making changes to this, that profile, I'm going to make some curve changes first. Changes to this are reflected in that profile. So this is how you can actually reference one to another and actually use that information to show how things appear from one thing to another. All right, that was a whirlwind view through all of the things that you can do from a basic level on profiles. I'm happy to open the floor to questions, but just to review, Jonathan, if you can show the last slide, please, that'd be great.
No problem.
Okay, so just to recap on what we've been looking at. So we've looked at the basic elements that are needed to create a profile. So you need to start everything from an alignment. Alignment is the holder of all information. And then from that alignment, you can extract elevation data from terrain models. So essentially your natural surface information. You then can create things called a profile view, which is a way to view that information in a graph that has the world kind of changed, where the x-axis is your alignment geometry in terms of length, and the y-axis is your elevation. Then the view can be enhanced, so you can start to design profiles over the top. So that's what we'll call a design profile or a vertical grading. And then from that, you can then begin to populate information in data bands underneath. So to make a long section like we would normally use in Australia, all of our data sits underneath in bands, which is what you can see here on the screen. And then once you've got all that stuff there, you can begin to enhance the view to show additional data. We could show crossing pipe networks. We can also show projected information from a variety of data sources. We can also label the vertical curve properties of our alignment and of our design alignment profile. We can also get horizontal geometry information based off the alignment from the parent perspective. We can also use these profile views to generate long sections of our pipe networks. So we've done that on a couple of different ways. We also showed how to look at adjusting the alignment extracted against the profile views for your branches on your pipe networks to start at the right values. You just edit the start station to match the branch value. And then we finished off with looking at superimposing from one profile to another. But yeah, as I said, a whirlwind on long sections. I think that there's more that we could potentially show on long sections in a potential future webcast to go into a bit more detail on a few things, and we could look at the super elevation stuff. But yeah, Jonathan, I'm happy to throw the floor open to any questions if there are any.
Yeah, thanks, Todd. No questions as yet. Guys, if you have got any questions, please pop them in the Q&A panel as quickly as possible, because we will be wrapping up the session very, very quickly. Just while we're waiting for any questions to pop in, I'm just going to make reference in the PowerPoint here just to the YouTube channel. So the webcast that you're watching now, if you go to the YouTube channel, which is youtube.com/civil service solutions, you'll see we have a Civil 3D webinars playlist front and center. And once you click on that, you'll see that the webcast that we discussed earlier, sections and section views, is, well, depending on your view, it should be at the top of the list here. But as you can see here, that's one of the latest webcasts we've done. So if you want to reference that in conjunction with the webcast that you've seen today, please have a look. No questions in the Q&A, so I think we might end the session there, which in that case, I'll just flip over to the final slide. The webcasts, as I said, they're recorded. If you want to get onto the mailing list to receive emails just simply about the webcasts or webinars, you're more than welcome to, using the link that's shown on screen there. And next week, to finish off July, we have a civil site design webcast presented by myself, where I'll be unpacking Auto Profile and Surface Extend, a couple of tools that were updated in that particular product in version 22 in around about May. Thank you very much, Todd, for that exhaustive and sorry, I think exhaustive is possibly the wrong word. I meant extensive, extensive
well,
unpacking
your
your profiles.
It was probably a bit exhaustive from the users to stick through for an extra half an hour. So I am really appreciative of everybody. I noticed the numbers are still, most people are still here. So I greatly appreciate everybody listening. And it's obviously stuff you want to know. So
yeah, definitely.
Apologise for going over time, but I think it was worth it just to show those last few things for everybody.
Indeed. Well, look, we hope you all stay safe and well, particularly at this time for multiple different states, and we look forward to seeing as many of you as we can at the next webinar. We will speak to you all soon. Thank you very much. Thanks, Todd.
Thank you, everyone. Have a good day.